Question number 10. This question is of integration. The diagram shows the part of the curve. This is a curve. The equation of the curve is y is equal to 4 over 2x minus 1 whole square, and parts of the lines x is equal to 1 and y is equal to 1. This line is x is equal to 1 and this line is y is equal to 1. The curve passes through the point A and B. These are the points A and point B. Curve passes through these 2 points. Find the exact volume generated when the shaded region is rotated through 360 about x-axis. We have to find the volume generated when shaded region is rotated 360 about x-axis. Clearly this shaded region is bounded by this line and this curve. When the shaded region is bounded by a line and a curve and rotated 360 about x-axis, then the volume, a formula for volume will be V is equal to integration of pi y1 square minus y2 square. We have to integrate this. Pi is just a multiple. Then we will take this is we will take this equation of the curve. This is y1. Suppose this is y1 and this line y is equal to 1. This is y2. y2 is equal to 1 and this is y1. So putting here the values of y1 and y2, v is equal to pi. We can take pi outside the integral sign. y1 square mean the square of this 4 over 2x minus 1 whole square. We will take its square. So 4 over 2x minus 1 whole square minus 1 square. Now we have to integrate this with respect to x, and the limit is point of intersection of the line and the curve. So limit is 1 to 3 over 2. We will take limit along x-axis. This the x coordinate of b is this 3 over 2 and this point 1. So limit will be 1 to 3 over 2. Writing here the limit 1 to 3 over 2. Now we will simplify it first, then we will integrate. V is equal to pi limit is 1 to 3 over 2. We can write this term 4 square is 16, 2x minus square whole square, that means 2x minus 1 power 4. So we can write it as 16 into 2x minus 1 power negative 4. Because we have brought this denominator in the numerator, sign of the power will be changed. 16 into 2x minus 1 power negative 4. 1 square is 1. Now we integrate it. Pi remains as such. Integration of first term will be 16 into 2x minus 1. We will add in the power, that will become minus 3, and same will be written in the denominator. And now the integration differentiation of inside the bracket, we will take the differentiation of this factor inside the bracket, that is 2x minus 1, differentiation is 2, so we will write in the denominator, and integration of 1 is x. So this is the integration. Now we will simplify it and apply the limits. Now simplifying it, cancellation, 2 8s are, now we will get here minus 8 over 3. V is equal to pi into minus 8 over 3, 2x minus 1 power negative 3 minus x, limit is 1 to 3 over 2. Now we will apply here the limits. First we will apply the upper limit, then lower limit. V will become pi minus 8 over 3, 2 into, we are applying the upper limit, in place of x we will put this 3 over 2, 2 into x is 3 over 2 minus 1, power is negative 3. Now we will put, we will insert here the sign of minus, negative sign, and now we will apply this limit 1, in place of x we will put 1. So just here also we will apply this upper limit in place of x, so this become minus 3 over 2, this is the upper limit, minus lower limit, minus 8 over 3, 1 power minus 3 minus 1. Now we simplify it. This will become v is equal to pi into minus 8 over 3, 2 power negative 3 minus 3 over 2 minus minus 8 over 3 minus 1. Further simplifying, b will be equal to pi minus 8 over 3 into 1 over 8 minus 3 over 2. Taking negative sign common from here, it becomes plus 8 over 3 plus 1. So this become pi. We will first we will simplify it and then simplify it, writing here pi into, simplifying the first term, we will get here minus 11 over 6, or simplifying this term we get here 11 over 3. Now we add these two fractions and will get the answer, that is 11 over 6 pi. This is the answer in exact form, because we have to give the answer in exact form. So this is the answer in the exact form. Exact form 11 over 6 pi. So next is part B of this question. A triangle is formed from the tangent to the curve at B, the normal to the curve at B, and x-axis. A triangle is formed from the tangent to the curve at B, the normal to the curve at B, and the x-axis. Find the area of this triangle. So in the given diagram we make a little construction so that we may have a triangle which is required, then we will find its area. Now we draw a tangent on B. This is the point B. Drawing a tangent at this point. This is the tangent at point B, and the normal at this point B will be, this is the normal. Normal and tangent makes a right angle. So this line is tangent and this is the normal. This angle is right because tangent and normal are perpendicular to each other. This line is normal, this line is tangent, and this is the x-axis. So this is the required triangle, the area of which we have to find. This is a right angle triangle. So we will find the area of this triangle. First we will find these points. We will find the coordinates of these points. Coordinates of B are already given. We have to find the coordinates of these points, which are the point of intersections of with the x-axis. These points lie on the x-axis. So first we will find the coordinates of these 2 points. Let we say this point is, let this point is A dash, and this point is B dash. B dash, this point is A dash. We will find the coordinates of these 2 points, A dash and B dash. So for this, first we will find the equation of normal tangent and the equation of normal. So for this, first of all, we have to find the equation of tangent and the equation of normal. First we find the equation of tangent. Equation of tangent. To find the equation of tangent, we have to find the gradient and the point through which the tangent passes. So it is very clear that this point is given because the tangent is on this point B. Point is given, but we have to find the gradient. To find the gradient, we will differentiate this equation of the curve. Differentiating the equation of the curve, we can find the gradient of the tangent. So y equation of curve is y is equal to 4 into 2x minus 1 power negative 2. We are differentiating it with respect to y, with respect to x. Differentiating this equation with respect to x. So dy over dx will be this minus 2 will be multiplied by 4, that becomes minus 8, 2x minus 1 minus 2 minus, we will subtract 1 from minus 2, this becomes minus 3. Again we will differentiate inside the bracket, that is 2, then we write here 2. So we get minus 16 over 2x minus 1 power 3. Now at point B, the x coordinate is 3 over 2. So putting here the value of x, that is 3 over 2. So we get the numerical value of gradient dy over dx will be at point x is equal to 3 over 2. Gradient will be 16 over minus 16 over 2 into 3 over 2 minus 1 power 3. Simplifying it, we get minus 2. So the gradient of the tangent is negative 2 and the point is also given, that is point B. So easily we can find the equation of the tangent. So equation of the tangent will be equation of tangent equation of tangent will be y minus y1 y minus y1 is equal to m x minus x1. Putting here the values, this becomes y minus 1 because the y coordinate of point B is 1, x coordinate is 3 over 2, and the gradient of the tangent is negative 2. This is the value of m. So we get y minus 1 is equal to minus 2 into x minus 3 over 2. Now this is the equation of the tangent, and since the tangent, look at this diagram, This is the tangent. This tangent line intersects the x-axis at this point A dash. Since the line tangent intersects the x-axis, so here at A dash the value of y will be 0. At x-axis y is equal to 0. So putting here y is equal to 0 in this equation, so we get the point. Putting here the value of y is equal to 0, we get 0 minus 1 is equal to minus 2 into x minus 3 over 2. Solving this equation, we get the value of x is equal to, we get x is equal to 2. We can get the value of x is equal to 2 because we multiply this minus 2 by this x and this is equal to negative 1. After simplifying it, we get x is equal to 2. So x is equal to 2 and y is equal to 0 are the coordinates of this point A dash. The coordinate of A dash are 2, 0. Now, similarly, we will find the coordinates of this point B dash. So for this, we have to find the equation of normal first. In the same way, first we will find the equation of this normal, then we will put y is equal to 0 because this normal also intersects the x-axis at this point b dash, y will be 0. So first of all we will find the equation of this normal. Equation of normal will be since the gradient of tangent and the gradient of normal are negative reciprocal to each other, so from here this is the gradient of minus 2 is the gradient of tangent, so gradient of normal will be negative reciprocal of minus 2, so gradient of normal will be m is equal to negative reciprocal of negative 2, that will be equal to 1 over 2. Point is same for tangent and normal. This is the point of the same point will be used for tangent and normal. Point is 3 over 2 1 and the gradient for normal is 1 over 2. So equation of normal will be equation of normal will be y minus y1 is equal to m x minus x1, y minus y1 m into x minus x1. Putting the values, we get y minus 1 gradient is 1 over 2 x minus 3 over 2. Simplifying it, no need to simplify it, but we have to actually we have to find this coordinate of this point. We have found the equation of this normal line, putting here the value of y because this intersects this point, this line normal line intersects the x-axis at this point, so at this point y will be 0. In the same way as we have found the equation of tangent, so y will be 0 at b dash. So putting here the value of y is equal to 0, we get x. Zero minus 1 is equal to 1 over 2 x minus 3 over 2. Simplifying it, minus 1 is equal to 1 over 2x minus 3 over 4. From here we can get the value of x. X is equal to, x will be equal to negative 1 over 2. So x coordinate of b dash is negative 1 over 2 and y coordinate is 0. So we are writing here the coordinates of point B, minus 1 over 2, 0, minus 1 over 2, 0. These are the coordinates of point B, minus 1 over 2, 0, and the coordinates of A dash are 2, 0, and coordinate of B point are also given. So we have all the coordinates of this right angle triangle. Now easily we can find the area of this triangle. For area of this triangle, first we have to find the base. I mean the length of B dash and BA dash. One length will be base, the other length will be perpendicular, because base and perpendicular uh, are uh, base and height are perpendicular to each other. So first we have to find the length of B dash and A dash, then we will find the area. So now we are finding B dash by using distance formula, writing here the points. A dash is 2, 0, B dash is minus 1 over 2, 0, minus 1 over 2, 0, and B point is given, that is 3 over 2, 1. First we will find B dash by using distance formula. Points are given, B dash. Using distance formula, B dash will be 3 over 2 plus 1 over 2, x2 minus x1 whole square, plus y2 minus y1 whole square. Simplifying it, we get 4 plus 1 under root, that means 5 under root. 4 plus 1 under root, that is 5 under root. Now we will find this length A dash B by using distance formula. A dash B will be 3 over 2 x2 minus x1 whole square plus y2 minus y1 whole square whole under root. Simplifying it, we get minus 1 over 2 whole square plus 1 whole square whole under root. After simplifying, we get A dash B will be equal to 1 over 4 plus 1. Further simplifying, we get 5 over 4 whole under root. So next one length is, because we have to apply the formula to find the area of right angle triangle. This is the base and this is the height. Formula for area will be 1 over 2 base into height. So area of the triangle will be area of triangle A dash B dash is equal to 1 over 2 base into height. 1 over 2 we are taking this height, this length is equal to base and this is height. 1 over 2 5 under root into 5 under root over 2, because we can write this 5 under root over 4 whole under root. We are taking under root of 4 is 2, so we can write it in this form. So final answer will be 5 over 4. Now we can give the answer and correct to three significant figure, that is 1.25. This is the area of the required triangle. This is the answer correct to three significant figure 1.25.